Okay, we're happening now. Causal inference, causal inference, and experimental design by Mr. Spock. No, this is actually Dr. Purdy here. So we're going to talk a little bit about causal inference, and talk about experimental designs, the criteria for inferring causality, discuss issues of validity, talk about various experimental designs, and then finally the threats to those experimental designs and external validity. So, what is causal inference? Well, first of all, inference is a conclusion that can be drawn logically given the research design and its findings. So you only conclude things based on what you've researched. So you infer from the data that you gather and how you analyze it, plus you infer from the sources of information that you included in your literature review. You don't infer from, for the most part, your personal opinion. Now, when we think about causal inference, we have a inference that implies that the independent variable, which remember is the thing that you, the researcher, are doing, or it is the thing that you believe causes something else to change, causes the dependent variable to change. So the dependent variable is usually the outcome of, for example, an intervention, decreased drinking, improved psychosocial functioning, etc. And the research design, of course, is everything that goes into the planning and conducting of a research project. Also, in order to have proper causal inference, there has to be a logic, a theoretical understanding of how one thing caused the other. So those criteria include things like the independent variable, which is the cause, must precede the effect of the dependent variable in time. So while that seems kind of fairly obvious, you find a lot of studies that that's not so obvious. Let's take, for example, a lot of the studies of substance abuse have used Alcoholics Anonymous attendance as a causative agent for reduced or eliminating alcohol use. So a person goes to AA, they stop drinking. Cause and effect. Makes sense. However, when we look closely at what usually goes on, people actually end up stopping drinking before they go to AA. So, for example, they end up going to treatment centers, or they go to jail. They have something happen that causes them to want to stop drinking, so they stop drinking. And then they end up going to AA ostensibly to support that decision, but really most we can tell from most research I've seen about AA attendance is that the two things happen. They went to AA and they have quit drinking. And usually the quit drinking, if you look at it closely, actually preceded in time the supposed cause. And so, it would be probably more accurate to say people go to AA because they've stopped drinking. Now we look at the two variables. They need to be empirically correlated. So you know, I guess we could stick with this AA quitting drinking phenomenon. If you look through a micro lens at some of the research around AA attendance, you'll see some correlation. You know, people who go to AA are more likely to not be drinking than people who don't go to AA, and who perhaps, you know, from a population of people who've had substance abuse problems in the past. So the two look highly correlated. But when you back off and you look more macro, using principles of epidemiology, for example, you'll find that I think the last research I looked on that was something like 37% of the population who quit drinking, who had substance abuse problems, didn't quit drinking. So there's one issue, and then there was another huge percentage. I should have pulled out that research before I talked about it. But there's a large percent that quit drinking without any kind of indicator of treatment, whether it be AA or anything else. So there's a large number that just simply quit, and then you have a smaller number that have improved or quit drinking because they attended some self-help group or went to treatment or therapy. So you can see that they're not really that well correlated. You know, quitting drinking actually correlates more with unknown than it does with this thing that is known. And then finally, the observed empirical correlation between the two variables cannot be due to the influence of a third variable that causes the two under consideration. So again, we'll stick with the AA example, and some of this comes from AA's own survey membership. When I last looked at their survey membership from about 2004, 2003, something like that, vast majority of the people who are in AA currently went initially because they were in some sort of legal trouble. So a judge somewhere said, "Young man, you better quit drinking and you better start going to AA." So judges seem to have a lot of power in this society. They can make people do a lot of things, and make people, go to jail, for example. And when they don't want to, most people don't want to. So, is it possible that a judge threatening somebody's life with incarceration, if they don't quit drinking, have an effect? We're certain. There's been plenty of research to show that. And also the judges often, even though there's been some court cases to say that that's unconstitutional because AA, because it emphasizes spiritual principles, has been kind of thought of by the Supreme Court as a religious institution, really does violate the separation of church and state. But anyway, they do it anyway. So, so the person could be going to AA because the judge told them to, and then they kept going because it gave them a social outlet, and so both of these objects may be caused by the same cause, which is the judge. So. In order for a a causation to be considered internally valid depends on a lot of things, including those three criteria we just looked at, whether it proceeded in time, the dependent variable preceded the independent variable preceded the dependent variable in time, the two variables were not empirically correlated, or the observed empirical correlation between the two cannot be due to the influence of a third variable. So, provided that those things aren't happening, we can look at other threats to validity of our causal inference. History. Now, history isn't the kind of thing that we studied in junior high and high school, about World War II and all that stuff. History is an ongoing thing. So whatever is going on concurrently with the research is considered history. So, for example, if you're doing a smoking cessation program, and at the same time there's a independently a large public health program to encourage people to stop drinking going on in that same community, it may be that the public health program had as much effect as your program did. And so you may not know whether or not your program is the thing that caused the change. Maturation. We think of maturation as a much the same way we think of the normal changes that happen in a human as they get older. We can predict certain changes will happen. Well, most sociological or biological or any kind of phenomenon have some sort of a kind of a predictable pattern that they go through. So, for example, if I was studying the common cold, for example, which we know is quite often, about 3 days long. If I get people into my study at the third day of their cold, and give them my magic pill, they're likely to be better the next day, and they're probably also would be likely to be better the next day if I didn't give them their pill. And so we think of something like a common cold, which is a brief disease. By the time we recruit people to come into our study and actually get them to sit down in our office, mostly their colds are already over, and it'll be done by the time we're done with our project. So similar to that, you can think of again, let's go back to substance abuse. There's just really no way that I know of studying substance abuse treatment except by receiving referrals from some source that has some sort of a coercion or influence on them. So it's not like you can go down to go here to Mike's Tavern on a Saturday morning and pick up the alcoholics and try a stop drinking group. mostly by the time people show up, they're well on their way to wanting to quit anyway. So they may have just quit. Matter of fact, there was yet another research project that followed up the no-shows for court-ordered treatment, and to the shock and surprise and embarrassment of the substance abuse treatment agency that was being tested, the people who never showed up for treatment did better than the people who showed up for treatment. And why did that happen? Well, because by the time they got around to getting into treatment, their decision to quit drinking had progressed enough that they had actually quit drinking. And then they figured they didn't need to go, and perhaps rightly so. Of course, testing is a threat to validity. When we test somebody, we tend to do some sort of a test-retest type of a situation in the social sciences. Well, in all sciences, but unlike biological sciences where one can draw some blood or put somebody on a scale, we have to administer some sort of an instrument and that they take, or we have to write down things that we observe about them that are not so objective. And so when we give somebody the same test twice, it is a threat to internal validity. Then again, when we change the instrument from pre-test to post-test, we also bring in a threat to internal validity. Are we truly comparing changes in the person, or are we measuring the change in the research instrument? So, statistical regression. Contrary to popular belief, it is not coiling up into a fetal state because you realize that I'm going to be talking about statistics. No, statistical regression comes from the fact that when somebody scores high on a measure, most likely the next time they take that same measure, they'll score lower, because that's just the way it works. You look, for example, you all took a pretest in this research course, and some of you had significant amount of knowledge about research, and others were, well, I ain't going to say it, but you could use some work. But that's why you're in a class. So those of you who maybe weren't too well prepared because you had no background in research, my guess is a number of those questions you simply guessed on, and your standard 4-item multiple choice question, you're probably going to get them right about 25% of the time on average. But some of you are going to get lucky and get them right 30% of the time, or 40% of the time, or even 75% of the time. When you think about the normal bell curve, somebody's going to get lucky. If I have enough people guess on 25 questions, somebody's going to get them all right, and somebody's going to get them all wrong. But most of them will get half and half, 12, 13 range. And so when those same people take that same test and they end up having to guess again, those who were lucky to get them all right the first time are not going to be the same ones, most likely, that are going to get them all right the second time. They're probably going to go back towards the middle. So whether we're thinking of high global assessment of functioning scores or low ones, high levels or low levels of weight, some of those kind of things, when we retest, those who score at the extremes are more likely to score closer to the middle. Okay, we talked about selection bias already in the previous chapters. Now, ambiguity. Again, going back to my discussion about the studies on AA and substance abuse remission. Was it the chicken or the egg? Was it AA attendance that caused alcohol cessation, or was it alcohol cessation that caused somebody to go to AA? Big question mark. Okay. In the range of studies that kind of fall under the word experimental, we have a variety of pre-experimental studies, and of those, the most common types are the kind of the one-shot case study, where you propose a new intervention with your mental health clientele, and then you give them the intervention and you test the outcome. So it's people that you're already working with, or a convenient population, and you describe what happens. A little bit higher up on the quality scale is the one group pre-test, post-test design. So maybe it's the same study, except instead of just testing them after the case study, you test them before and after. And both of these are a comparison to something. The one-shot case study is a comparison most likely to some either known or theoretical standard. The other one is an actual test of the self, of the group itself. And then finally, the next step up the quality ladder of research design is a post-test design with non-equivalent groups, and that's the kind that has only a comparison group that doesn't get any stimulus. So here we have the one-shot case study. It's it's not a very valid study. I mean, it is what it is. I'll give you some insight into what's potentially going on, and the researcher makes an intuitive judgment. It might also be a clinical judgment, as to whether the results are good or bad, or high or low. Now, the pre-test, post-test, again, is a little bit better than that, because in this case, where we have to have some sort of a standard that may be arbitrary, it may be normed on some population. This one, we're actually comparing the group against itself. So we do a pre-test and a post-test, which establishes whether or not something is correlated and that there's a time factor. But again, it doesn't eliminate other factors that may be causing the change in the dependent variable. Some people will then say, "Well, I'll just have a comparison group." So they'll give their new case management protocol to their group and compare it against the group that goes across town to the other mental health center, and then they'll compare those two. It's like, well, ours are doing 7 on a rating scale of 10, and theirs are only doing 6. So, my research must have proven that my intervention worked. Well, it didn't prove anything. You're just maybe getting an idea that it might work, but you can't infer that there was any difference between the two to begin with, that they were the same to begin with either. You don't know anything about these two groups. You didn't test them before. So testing before, testing after, testing between two groups is kind of the hallmarks of experimental designs, true experimental designs. And they're the strongest evidence that we have for making causal inferences using research. And Rubin and Babby used their what's the word? They use letters to represent different things, and in this case, and throughout the rest of the book, they use the word R. Big R means a random sampling has happened. So in this case, we have two R's. That means we've got two groups that were drawn from one population and split into two. And in this group and in this group, we observed. That's what the O always is in Rubin and Babby's. With the little number 1 means it's the first observation. So they're selected, put into two different groups, and observed. Here the top group gets the experiment or the intervention, and the bottom group gets nothing, which means they're a control group. And then finally they're observed again, O2. It doesn't mean oxygen, it means O2. Observation 2. The experimental group gets measured on the dependent variable, gets the intervention, and then gets remeasured. And the control group gets measured and then remeasured at the same time. And we compare if they're the same at the outset, and it's important that they be the same at the outset. For example, if we want weight loss, and this group starts off 10 pounds heavier than this group on average, and it ends up being 10 pounds heavier than this group on average after it's all done, even though this group is lighter, and that's our goal, it doesn't mean our intervention did anything. It means they started out heavier. So the pretest, post-test does not control for the impact of testing and retesting. So sometimes to avoid the test-retest, particularly when we use survey instruments, the researchers will not do a pretest and rely on the fact that the random assignment has created equivalent groups. And if you have a large enough group, that's something you can do. But if you get down in the lower numbers, 20 or so people in each group, I wouldn't hang my head on it. So to get around that, and to understand the effect of pretest or the testing effect, Solomon designed this 4-group design, which again they randomly sample from one population into 4 different groups. So group 1 gets observed, group 2 gets observed in a pretest. Group 1 then gets the intervention, group 2 gets nothing. Group 3 gets the intervention, group 4 gets nothing. And then finally, when it's all said and done and your research is over, everybody gets observed at time 2. And what happens then is that group 1 gets compared to group 2, group 3 gets compared to group 4, group 1 gets compared to group 3, group 2 gets compared to group 4. So there's all this kind of comparison stuff that goes on to see if there's any difference between these two groups. So for example, if there is no difference between 1 and 2, but there is an improvement in 3, but no improvement in 4, then we could infer that there was a testing effect, or I should say it the other way around. Right. So I did say that right. So if 3 is better than 4, and whether or not and these two are equivalent, we should probably suspect that the test-retest is problematic. So sometimes, in order to kind of differentiate between different types of treatment, people will be randomly selected into 2 different treatment designs, and this is often done when social work interventions, like they always are very complex. So often there will be pieces added or not added, whether it be, group A gets 12 interventions of substance abuse treatment, group B gets 8, and so they compare that to a control group that gets none. Other times, when you have one study, you're studying one intervention, not comparing one against the other, you will study that intervention in its completeness. For example, the example they use in the book is a great one about EMDR. EMDR is a method of processing information through the use of visual movement of the eyes, and it requires, a trained psychotherapist to do it. So what they did was they deconstructed EMDR and included in group A, I think it was just the eye movement part, and then in group B, it was just the psychotherapy part, and then group C, or the 4th group, was just a control group, and they got no intervention. And in the case of the EMDR, there wasn't a lot of difference between those who got EMDR, full protocol, and psychotherapy only. There was a difference between that group and those who got just the eye movement. The XAB was better, and the XA was better than XB, and I believe they were all better than the final one. So essentially, what that did was to demonstrate that but there wasn't a statistical difference between the control and the eye movement only. So what that demonstrated was that it wasn't the eye movement stuff that had anything to do with the improvement. It was just the fact that they were getting psychotherapy. So if one can randomize their sample, that's the best guarantee that you're going to get a bias-free experimental group. It doesn't preclude that, but it just improves the likelihood that your group that doesn't get the intervention is going to be similar to the group that does get the intervention. To improve on randomization, we'll often match within randomization. So say, for example, when we randomly select 100 people to go into 2 groups of 50, we will then look at the 100 people and then randomly assign based on gender, for example. So then we get roughly equal numbers of genders in both groups. Sometimes we'll look at gender, age range, and randomly. So sometimes these random selection processing with matching can get quite complex, but it does make for a better research design because the groups become much more comparable. There are ethical considerations with putting someone into a control group. A lot of the services that social workers provide are to the neediest of the needy, and so when we put them into a control group, many social workers object to not giving a needy person a service. Well, so that's true, but on the other hand, if you don't know whether or not a service is effective or not, then you're not being unethical. Matter of fact, you may be unethical in giving them a service that is not proven to be effective. So there's this kind of conflict of two different ethical principles, plus the ethics of human subjects and the ethics of the social worker. So it makes for a lot of critical thinking. Often, one way around that is go ahead and just give whatever standard of care to the control group and compare to see if the experimental group does better than treatment as usual. Sometimes control group people, when there is a wait list to receive services, in exchange for agreeing to go into the study, the person who ends up selected into the control group will go on to the top of the wait list. So you've got bias in how we try to get around the bias of selection by doing random assignment, but that doesn't get rid of all bias. We just, any of our social instruments that we use to gather information about people are going to have some inherent bias to them, and that's just something we have to deal with, and we have to face, kind of head on and deal with. And so, here's my notes. Excuse me. Of course, when we create measurement instruments, we want to make sure they're not biased, based on culture or gender or some of those kind of issues. But a lot of times when we do research, observational research, people have to rate something. They have to, oh, this person's a 7, this person's a 3, this person's a 9, whatever. And we have to make sure that our raters agree. So we have to ensure that the thing that we are observing is logically related to what we're calling it and how we're rating it, and two, that two different people using the same criteria are going to rate the same phenomenon relatively equally. One of the things about research is that it's a human process, and so you become engaged with a human subject, and they're going to do all the things that human beings do. And one of those things is they'll try to respond to you, the researcher, and understand what you want, and so that they can give you what you want. So we see in medical studies, this is such a real threat that the patient will want to do what the doctor, they think the doctor wants them to do, that in drug studies, it's the norm that the person administering the drug, the nurse or whoever, doesn't know whether or not they're giving an actual pill or not. All they know is they're just giving somebody a pill. They're giving somebody a shot of experimental vaccine, etc. And they do this because people read people's expressions, their body language, and know what their expectations are. So if you let that nurse know that you're giving, that they are administering sugar pills as a placebo to somebody, then that's going to get transmitted. When we think of diffusion or imitation treatments, this is especially rampant when doing treatment in agencies, because quite often we want to implement a intervention in one section of an agency and not in another. Like, say, for example, you have 2 offices or 2 treatment teams or something like that. Well, one of the things that often goes on, if you compare, case management team A with case management team B, is that case management team A has gotten the training word gets out what they're doing, usually through the grapevine or their clients or somehow. The treatment team B says, "Oh, this is that new thing they're doing. Well, let's try it." Or the other thing that happens is treatment teams won't fully implement a model. So when it happens that there's a group of people who are known to one another, one who's doing the new intervention, one who's not doing the new intervention, they try to, and they got these fancy names like compensatory equalization. What that means is treatment team B, they just try a little harder to make sure that treatment team A doesn't show them up. So there's this kind of sibling rivalry thing going on, and or sometimes at the other extreme, there's this resentful demoralization. Oh wow, treatment team A, look, they got to go to Hawaii for this training, for this new method. Oh, aren't they special? And so they got a bad attitude, provide bad service. Next thing you know, their outcomes are lower than treatment team A, not because treatment team A is doing a better job. It's just doing it because they're unhappy. So, and finally, some other threats with both experimental and pre-experimental and quasi-experimental findings is the whole subject of attrition or experimental mortality, not the kind of mortality that people die, but that people drop out of treatment. And depending on your treatment, it may be important to understand and compare the difference between those who dropped out and those who didn't. So be clear about your consent forms. Be sure to say that somewhere along there that all information gathered up till the time of withdrawal becomes the ownership of the researcher. So, for example, if you tell them that they can drop out of the research at any time, and you will not use any of their information, you won't be able to see if the people who drop out are any different than the people who stayed in. So, word to the wise on that. Okay, we already talked about that. Talked about research. Placebo groups, another type of experimental design where one group gets the intervention, another group gets a control, another group gets a fake intervention, one that isn't believed to have any effect. And that's hard to do in social sciences because a person almost needs some level of training to be able to do what social workers do, or at least to pretend that they do. And most people are not so naive that they wouldn't recognize somebody who's playing at being a social worker versus one who actually is. So, already talked about these topics. All right.